First, let's review linear inequalities by sketching a graph for each of these functions. When you graph these, I don't care how detailed your graph is. Some math teachers would say that you need to put every single mark between -3 and +1. I really don't care. Put -3 on the graph, put 1 on the graph. We need to remember, when do we use open circles, when do we use closed circles, and how do we shade for inequalities? X is the shaded stuff, and notice in this inequality, this is considered an AND inequality. In this AND inequality, X needs to be bigger than -3 and at the same time smaller than 1. So X is going to be the numbers in between, like in through here, in between -3 and 1. Should we put an open circle at -3 or a closed circle at -3? Open circle. When it's plain less than, you do an open circle. Less than or equal to, you use a closed circle. So at 1, we will do a closed circle. And X is the stuff in between. So we shade in between. B is written poorly. You should never leave your answer written like this because it's very misleading. This says -3 is less than X. If -3 is smaller than X, that means that X needs to be bigger than -3. To make things easier, you should always rewrite this with the X on the left and the -3 on the right. Your symbol is currently eating the X, so make sure your symbol is eating the X. This is really X is greater than -3. So on a number line, when there's only one number, I like to also put 0 on the number line just to kind of orient the number line a little bit, but you don't need to. I won't count off if you don't. This is an open circle at -3. We want to shade the X values that are larger than -3. That would be to the right. There is the trick of your inequality symbol shows you which direction to shade. If it's a greater than symbol, it's pointing you to shade to the right. That only works when your X is written first and the number is written on the right. All right, try the last one on your own. Okay, closed circle at 2 because it's less than or equal to. If it's got that equal to line on it, you definitely need the closed circle. Less than, smaller than 2, so the numbers smaller than 2 are to the left. When we solve linear inequalities, you really treat the inequality just like you would an equation. So the steps that you would follow to solve an equation, you do the exact same thing. There's just that one little rule that if you multiply or divide by a negative number, you have to take the sign and flip it. You have to switch the sign. So if we get to a point where we have to multiply or divide by a negative, we would have to change that sign. Subtracting by 3x does not change anything. So we have 2x minus 7 is greater than 9. I would add 7 on both sides. And then I would divide by 2. X is greater than 8. The directions do say solve and sketch the solution on the real number line. Open circle at 8. X is the shaded stuff. The shaded stuff has to be bigger than 8, so we shade to the right. In example B, what should we start with? Subtracting 4. That will leave us with negative x over 2 is greater than or equal to negative 7. How do we undo divided by 2? multiply by 2. Now my only problem is I still have a negative in front of the x. How do we get rid of a negative in front of the x? Divide by -1, and when you divide by a negative, you must flip the sign. So this will become x is less than or equal to positive 14. So if we draw ourselves a number line, closed circle, shaded to the left. When you have a double inequality, this actually feels more like a triple inequality because there's 3 pieces to this. There's the left, the center, and the right. But it really is a double inequality. This is 0 is less than or equal to 3x minus 5, and 3x minus 5 is less than 1. So there's 2 separate inequalities connected with the word and, so we shove them together into one 3-part inequality. When you're solving this type, think of it as 3 sides. There's the left, the center, and the right. Your goal is to get just x in the center. So do what you need to do in the center to get x by itself, but whatever you do in the center, you must also do to the left and to the right. So if we want to get this x by itself, what's the first thing we need to do? Add 5 to all 3 sides. 5 is less than or equal to 3x is less than 6. And then divide by 3. If you want to leave this as 5/3, you can. If you want to change that to a decimal to make it easier to graph, that would be fine as well. I believe that's the decimal 1.67. So 5/3 is less than or equal to x is less than 2. And then just to make sure that we're good on this type of graph, 1.67, 2, closed circle for 1.67, open circle for 2, shade in the middle. In this 3-part inequality, there's a little bit more going on. Where do you think we should start? Multiply by 2 on all 3 sides. That will give us -10 is less than or equal to 3 minus x is less than 8. Now what? Here's where I usually see the first error. Do you see how it says 3 minus x? A lot of people see that subtraction sign and so instantly think, oh, I need to add 3 on both sides. But is that the correct step? No, this is a positive 3, so we need to subtract 3 on all 3 sides. That will give us -13 is less than or equal to -x is less than 5. Now, before we continue, I want to point out that these 3-part and inequalities are always formatted in this way. The smaller number less than x less than the bigger number. Do you agree that -13 is smaller than 5? Okay. Now what do we need to do next to get rid of that negative in front of the x? Divide by -1. And when we divide by -1, we have to flip those signs. We will have positive 13 is greater than or equal to x is greater than -5. Now, notice that -5 is the smaller number, and it's all the way over on the right, and those symbols have all been switched. This is a true statement. 13 is larger than x, and x is going to be larger than -5, but we don't want to leave it like that. So instead, we need to reverse it. It's going to seem like we're switching the signs again, but we're really not. Okay? In between -5 and x, the sign is eating the x, and it's a plain sign without the equals to line. So notice here, I've got that symbol. Between x and 13, the sign is eating the 13, and it has the equals to line on it. Really, we're taking that statement and we're just reversing it around. And now this is correct with smaller number less than x less than bigger number. To graph this, you would number line -5, 13. Open circle at -5, close circle at 13, shade in the middle. Oopsie. Went a little crazy with my shading, man.